Hi, we're from Chile, and today we are going to present you the talk Training Novae Hunters using Life Curve of Novae for Mathematics Learning in the School Classroom. Chile is a geographical privileged country for astronomical observation and research in the world. However, there is a lack of astronomy content taught at the school level, a situation that is also observed in OECD member countries. To address this problem, CIRAS pedagogical team was established in 2021 by the University of Santiago of Chile and the Center for Interdisciplinary Research in Astrophysics and Space Science. The team, which is comprised of high school science teachers, astrophysics, specialists in educational science, and pedagogy students. The object of the team is to co-design activities based on the use of authentic data from different lines of research in astrophysics. With the purpose of bringing frontier astrophysics topic to the school classroom, in this work we present the creation of educational activities to be taught in the subject of mathematics and in accordance with the learning objective of the secondary school curriculum in Chile, using time-resolved photometric data for the construction and analysis of the novae light curve obtained in the LCO telescope network. This activity is based on the novae reaction, which is a thermonuclear runaway triggered on the surface layer of a bright draft as a consequence of the accreted material from the light-type main sequence star in a cataclysmic variable star. The eruption is observed as a sudden rise of brightness that can amount to up to approximately 16 magnitudes. A light curve of brightness decay is evident as a function of time following the eruption. The climb light curve of novae can be complex, showing a multitude of phenomena like oscillation, plateaus, rebrightening, etc. And the physical origin of many of these phenomena is still unexplained. Now we present our work methodology. Our work plan consists in 6 major stages. Analyze the academic curriculum to identify learning objectives between physics and mathematics that could be worked on together, and the corresponding topic were selected. Then the construction of didactic activity using real data from novae eruption obtained by our team. The implementation of the activity created in the school and the team's teachers. Collect and analyze data to understand the impact of the experience. Based on the result, the activity are reviewed and improved if necessary to obtain a definitive version. And finally, we share with other teachers and transfers to other schools to promote its replicability, mainly through workshops. The learning objective apply models that describe phenomena or situation of growth and decay that involve exponential and logarithmic function is a math learning objective. Two separate activities were carried out in 2 parts each. In the first activity, we work with real data to graph and model curve that later, in the second part, were analyzed by the same student. While in the activity 2, first part, we work with real data, which were analyzed in which allow. Finally, the student to compare light curves. In order to bring novae into the classroom during 2022 and 2023, we acquired observing time with the Training Novae Hunters project in the Global Sky Partner program, which is part of the Las Cumbres Observatory. During 2023, we gained access to conduct our own observation to construct the light curve of novae that had experienced recent eruptions. Through this project, we tracked nova SCO 2023, which erupted in April 20th of this year, reaching a maximum magnitude of 8. From that point on, we maintain continuous monitoring, acquiring 3 to 4 observations per night. It's worth noting that LCO provides calibrated image along with a photometric data table for each image. Additionally, we improved the data acquired from NOVA SCO 2023 by incorporating information gathered by amateur astronomers worldwide from the American Association of Variable Star Observers database. In addition, we download light curve data from various categories of past novae to be utilized in our teaching sequence.
These activities were implemented in mathematics class for 87 students of 16 and 17 years old. The implementation was carried out in 3 classes of 45 minutes each, after the students have had formal lectures of exponential and logarithmic functions. The students worked in group of 3 and responses were collected digitally. Additionally, an individual entry and exit ticket was applied. So now the results. In activity 2, each student's group was given a table of magnitude and time data for a recent or historical nova. With this data, they created the corresponding light curve and identified the corresponding mathematical function. With this graph, all the students were able to deduce and understand that in a nova, the brightness decay over time. It was also possible to establish comparison between the decay time of different novae and outside, in order to discuss the factors that influence the phenomenon. At the end of the implementation, we invited students to grade questions that they would ask an astronomer, based on the activities carried out. This question fell into 4 categories, reflecting the diverse range of inquiries that often arise when teaching mathematics with real data. For example, some saw graded understanding about specific topics in astronomy. Others were curious about the nature of astronomers' work and their underlying motivations. In general, 95% of the students evaluated positively the experience. In his opinion, the use of astrophysics in mathematics class allows them to be less abstract. The students responded positively to working with recent astronomical events, as it allowed them to stay informed about the current development in astrophysics research. Finally, it is important to highlight that the students responded positively to working with data from recent astronomical events because they can learn about what is currently being investigated in the world. Finally, the conclusions. The activity has facilitated the incorporation of cutting-edge astrophysics concept into mathematical class, encouraging the utilization of authentic data for contextual and situated learning. With these activities, it becomes possible to stimulate students' interest in mathematics and curiosity in scientific research. Finally, we think that collaborative work between scientific and teachers is the key for impact education. Thanks for your attention.